All right, so today's lesson, dilations. Dilations. Colt, do you realize that you have zero awareness of anything that is going around you? I'm talking and you just think it's okay to sharpen your pencil.
You said dilations twice and then stopped.
Well, because you just walked right over to sharpen your pencil. Are you aware? There's a sharpener right next to you.
That one's louder.
Get together. Trayshawn, your dilation notes, get those out. That's where we're going to start. Okay. So in each of the following pictures below, the number 1 is labeled as the image, and sorry, the original is number 1. So the number 1 is your pre-image. Yes, I know you're frozen. I'm getting it. Number 1 is your pre-image. So the first thing that I would do is I would find the number 1 of each item and I would label it pre-image. And remember, pre-image means original. So this is my pre-image, which means this is the image, the new shape. This is my pre-image. And the new shape is the image. Okay, so that's just your vocabulary from the beginning. So when you talk about a dilation, we talk about a change in size. So dilations are different than the rigid transformations that we've been working with. So a dilation is still a transformation, but it's not rigid, because rigid means that it keeps the same shape and size or preserves congruency. And dilations make them larger or smaller. So if you were to look at the original item, and you were to look at the new item, and I don't know if you guys can see this or not, but this has a 1 inch next to it. Did the new item get bigger or smaller? So it got smaller. So this dilation is called a reduction. And when you want to figure out the scale of the reduction, the scale factor or the scale, you take the new over the original. So the new measurement is 1 over the original measurement is 4. So that just means that we dilated that object by a scale factor of 1 over 4. We dilated that object, or we reduced it by 1/4. Raise your hand if you need more time with that. All right, I'm going to move on to the next one. So when you look at your next image, and you try to determine the scale factor, let's first off decide if it's a reduction or an enlargement. Did it get bigger or smaller? Bigger. So this is an enlargement. And when I think about the scale factor, if I want to find the scale factor, I take the new measurement over the original. So the new measurement is 11 over the original, which is 0.5. So what is the actual scale factor? What is 11 divided by 1/2? It's not 11 divided by 2, it's 11 divided by 1/2. 11 divided by 2 is 5.5. 11 divided by 1/2 is 22, right? So this means it was the scale of enlargement is 22, is made 22 times larger. Okay. Questions? It's really not, but according to the numbers it is. Right? If this is 1/2 inch and this is 11 inch, yeah. Volume is, so that's a really good question. Area, when you think about scale in terms of area, you square that number, and volume, you triple it, you cube it. Okay. Well, that's really a math 3 concept, but I'll show you when we start doing some more stuff. Okay. So to find the scale factor from 1 to 2, remember I said, so to find the scale factor, you are always going to take the image, which is the new item or the new shape, and put it over the pre-image, which is the original. Okay. When the scale factor, like in our first example, when the scale factor is less than 1, you have a reduction. Okay. In our second example, our scale factor was 22. And we know that that's an enlargement because it's greater than 1. So when your scale is less than 1, you have a reduction. When it's greater than 1, you have an enlargement. Less than 1 is a reduction. Greater than 1 is an enlargement. So dilations are not congruent to each other. When you dilate something, they're not congruent, right? Because the size of the shape changes. But they are what? If they're not congruent, but what means that they're like they still look the same? What is that word that we use that means looks the same in math? Do you guys have any idea? Nope. Begins with an S. Similar. So the pre-image and the image are similar. So I'm just going to write exactly what we wrote again for those of you that didn't get it. So I know, what do I know about a reduction? So the scale factor, K, that's how we represent our scale. We use the variable K, is less than 1, but it's greater than 0. So K is really a positive number, right? And we know how to find it, right? We take the new over the original, or the pre-image is made bigger. Like we take the pre-image and we make it smaller for a reduction. Pre-image is made smaller. Where when we enlarge something, we know that K, our scale factor, is greater than 1. And we're actually taking the pre-image, the original item, and making it bigger. Okay. So what if the scale factor was 1? That's what it says down below there. What if the scale factor is 1? We didn't talk about that. It doesn't change. Yeah, it stays the same. It stays exactly the same. So there is no change in the size. And actually, if that's the case, the two images are congruent. So if you don't change the size at all, then the two images are going to be congruent. If you have a scale factor of 1, that just means keep it the same. So we're going to start our first example. It says the shaded triangle is the image. Remember, the word image means new. The shaded triangle is the image, and the unshaded triangle is the pre-image. So this is the guy, the little pre-image, and this is the image. And yes, it is an enlargement. Thank you, shout out Parker. Are we going to do that all the time?
Yeah.
Shout outs? Yeah. No, you're not. Yeah, okay. So what's the scale factor, Kane? How am I going to figure out the scale factor? So remember, you're going to take the image, any of the measurements on the image, and put it to the corresponding pre-image. So what's that going to look like? What numbers are you comparing?
12 and 3.
Okay, so you can put 12 over 3. Can you put 16 over 2? Let's look at 16.
No, it's the same number as 12.
What does 16 represent? The base of the triangle, right? So you have to compare the same like the corresponding parts, right? So you can only compare the 12 and the 3. You don't know the measurement here to compare to 2, and you don't know the measurement here to compare to the 16. So this actually has a scale factor of 4, which also confirms that it's an enlargement because it's greater than 1. Okay, so I'm going to write k equals 4 because that's how you're going to see it. K equals 4. Is everybody good with that? Does this make sense? Okay. So now you're going to determine whether the dilation from W to W prime is an enlargement or a reduction. So W is this little tiny triangle down here. W prime is the larger triangle. So let's figure out, first of all, if it's an enlargement or a reduction. What do you think, Nathan? So this is the first image. This is the pre. And this is what I did to it. Go ahead, Draco. It's an enlargement. So when you think about the scale factor, this 16, do you guys see this value right here of 16? That's comparing the whole, like this whole distance from the beginning and to where it ended. So that measurement actually goes with the image, right? The new object. The new object has a measurement of 16. The original, the pre-image, has a measurement, I don't know if you guys can see that down here, of what? Of just x. Okay. But what is this distance right here? 10. So, which is the distance. So think of it like this. X plus 10 equals 16, right? So x equals 6. Good job. So we really have 16 over 6, which reduces to what? Can we divide by 2? Yes, 2 2/3. Or can I just leave it as 8 over 3? Okay. So that's what K is. K is 8 over 3. When I look at my next image, W, the original shape. So the original shape W is 22. W prime is made smaller, right? And it has a measurement of 14. We don't need to do anything with the X there, right? You don't need anything with the X. Okay, so is this an enlargement or a reduction? It's a reduction. Good job. We're making it smaller. You're always looking at W prime because remember that's the transformed shape. So 14 over 22, we can divide that by 7. Oh, no, we can't. We can just only divide by 2. And that gives us what? 7 over 11. So K equals 7/11. And in this first example, K equals 8/3. 8/3. Tyler, were you the one that said it's 2 2/3? Or was that Zach? Okay, so we know that the first one has a dilation or scale factor of greater than 1. The second one is less than 1. Questions? Okay, go to the next one. So to create the illusion of a life-size image, puppeteers use a light source to show an enlarged image of a puppet projected on a screen or a wall. Suppose that the distance between a light source, L, so this is my light source right here, And the puppet in inches it's 24. So the distance from the light to the puppet is 24 inches. That's that measurement right there. I can actually just draw a sketch of it. So 24 inches from here to here. Okay. And it says to what distance P from P to P prime should you place the puppet from the screen to create a 49-inch tall shadow. So we're trying to figure out this distance right here to make a shadow that is 49.5 inches tall. Okay. Well, the first thing that we need to know is how tall the original puppet is. How tall is the original puppet? What does it say right here? Yeah, it's 9 inches. So originally you have a 24, like a distance of 24, and this measurement is 9. And that's going to be compared to this whole distance of 24 plus x and 49. We're going to set up a proportion. Do you guys remember using proportions? Yes? Okay. So I'm going to set up 24. That's the distance from the light source to the height of my puppet, equals the whole distance from the light source to the new puppet or the shadow, which is 24 plus x over the whole height of the puppet, 49.5. How do you solve a proportion? Think back to your Math 1 or algebra days. How do you solve a proportion? Do you guys remember if I do something like this? What am I doing here? Yeah, it's, oh, crud. That shouldn't have done that. Yeah, it's called the cross product. Cross product or cross multiply. So I need to know what 24 times 49.5 is. Well, tell me what it is. 24 times 49.5.
1,180.
Say again.
1,180.
1,180. Thank you. Equals 9 times 24 is 216 plus 9 times x, because we're taking 9 times this whole thing. So it's like essentially getting distributed. So now what are we going to do? Subtract 216 from both sides? Isn't that 972? Equals 9x. Divide both sides by 9, and I find out that x equals what? Should be 108. And don't forget your unit, inches. So we just calculated this right here. We just calculated this measurement right here. Okay. That's a scale factor kind of using similarity and proportions. Okay. Your fabulous geometry teacher draws a perfect freehand circle on her tablet computer and then projects it through the overhead projector. The projector then displays an enlargement of the perfect circle on the board. The circle drawn on the tablet has a radius of 3. The circle on the board has a radius of 3 inches. The circle on the board has a diameter of 4 feet. What is the scale factor? So let's do some comparing really fast. Maybe. thinking about working. Okay, here we go. So radius is 3 inches. The large circle on the board has a diameter of 4 feet. So if the diameter is 4 feet, what is the radius?
2.
Yep, the radius is 2. Notice that we have our dimensions in feet and inches. We have our dimensions in feet and inches. Do you think that we can do that, or do we have to have them all the same unit?
All the same.
We all have to have the same unit, yeah. So we either need to turn the 3 inches into feet or the 2 feet into inches.
3 inches into the feet.
Okay, so how many inches are in a foot?
Oh.
12. 3 over 12 is the same thing as, so this is 1/4 of a foot. So I'm taking the image, which is the new shape, over the pre-image, which means I have 2 divided by 1/4. 2 divided by 1/4. You just put that into your calculator. 2 divided by, parenthesis, 1 divided by 4. No, it is not 0.5. Yeah, 8. Very good. So your scale factor equals 8. Okay. So make sure that your units match. Could we have turned this 2 feet into inches?
Yes.
Yeah, that probably would have been easier. Maybe you would have seen it. 24 inches over 3 inches equals 8. Okay. All right, next one. Dilations in the coordinate plane. So when we do dilations in the coordinate plane, they're always going to be centered at the origin. So the first thing that I want you to do is graph your original image, trapezoid EFGH. So make sure you plot your points once you get them on there. Once you get your points plotted, make sure you connect your lines because we're making a trapezoid. So when we talk about scale factor, our scale factor is 1/4. The way that we find the coordinates of the new image is we take each ordered pair and we multiply it by the scale. It's called scalar multiplication. So what is 1/4 of -8? Or -8 divided by 4 is, so the x coordinate of E prime is -2. What's, and comma 1? 1/4 of 4 is 1. So F, -4 times 8 equals the scale times -4 times 8. So F prime becomes what? Well, 1/4 of -4 is
1.
-1. And 1/4 of 8 is,
Positive.
yep. We do the same for G. So you take each point and you multiply it by the scale. Again, it's called scalar multiplication. You might see that. So 1/4 times 8 gives me an ordered pair of 2, 1 for G prime. H started out as the ordered pair -4, -8. When I multiply each one of the coordinates by the scale factor, what do I get for H prime? -1 and -2. So I'm going to plot those points. I'm going to plot E prime, F prime, G prime, H prime, and connect my ordered pairs. So E prime, F prime, G prime, and H prime. So the image, the finished product, is this teeny little trapezoid right down there. So there's something cool about graphing when you graph and you enlarge or reduce from the origin. So you'll notice that if I were to start at the origin, I can go right through point G prime and E prime with a straight line. I also go right through the origin to point F prime with one straight line. Why is that? Why am I able to do that? Yeah, it's similar, right? It's similar. And this, when we think about this, this is keeping the slope the same, right? When we are able to draw a line through it and it touches each point, it just means that the slope is staying consistent. So we're actually reducing it to the center. Okay? So maybe that'll help you. And that honestly is your lesson. That is your lesson for today. So I'm going to write down what your homework is. Hang on a second. So lesson 1.4 homework is dilations. You have, it's just questions 1 through 8. But you also have your project, because remember I told you today would be a project day. So you have your project that you need to work on. Okay, because today is the only other project day that you have besides the Friday that it's like before it's due. Okay, did you look at the module at all while you were out? Okay, well,